Petroleum, from medieval Latin petroleum, from Latin petra rock, see petrous, plus Latin, oleum oil, is a naturally occurring, yellow to black liquid found in geologic formations beneath the Earth's surface, which is commonly refined into various types of fuels. It consists of hydrocarbons of various molecular weights and other liquid organic compounds. The name petroleum covers both naturally occurring unprocessed crude oil and petroleum products that are made up of refined crude oil. A fossil fuel, petroleum is formed when large quantities of dead organisms, usually zooplankton and algae, are buried underneath sedimentary rock and subjected to intense heat and pressure. Petroleum is recovered mostly through oil drilling. This comes after the studies of structural geology, sedimentary basin analysis, reservoir characterization. It is refined and separated, most easily by distillation, into a large number of consumer products, from gasoline and kerosene to asphalt and chemical reagents used to make plastics and pharmaceuticals. Petroleum is used in manufacturing a wide variety of materials, and it is estimated that the world consumes about 90 million barrels each day. The use of fossil fuels, such as petroleum, has a negative impact on Earth's biosphere, releasing pollutants and greenhouse gases into the air and damaging ecosystems through events such as oil spills. Concern over the depletion of the Earth's finite reserves of oil, and the effect this would have on a society dependent on it, is a concept known as peak oil. Etymology: the word petroleum comes from Greek, I plus or minus for rocks, and Greek, a 1/4 I plus or minus I to the first I 1/2 for oil. The term was found in 10th century Old English sources. It was used in the treatise De Natura Fossilium, published in 1546 by the German mineralogist Georg Bauer, also known as Georgus Agricola. In the 19th century, the term petroleum was frequently used to refer to mineral oils produced by distillation from mined organic solids such as cannel coal, and refined oils produced from them. In the United Kingdom, storage of these oils were regulated by a series of petroleum acts, from the Petroleum Act 1862 onwards. History. Early history. Petroleum, in one form or another, has been used since ancient times, and is now important across society, including in economy, politics and technology. The rise in importance was due to the invention of the internal combustion engine, the rise in commercial aviation, and the importance of petroleum to industrial organic chemistry, particularly the synthesis of plastics, fertilizers, solvents, adhesives and pesticides. More than 4,000 years ago, according to Herodotus and Diodorus Siculus, asphalt was used in the construction of the walls and towers of Babylon. There were oil pits near Ardrica, and a pitch spring on Zacynthus. Great quantities of it were found on the banks of the river Issus, one of the tributaries of the Euphrates. Ancient Persian tablets indicate the medicinal and lighting uses of petroleum in the upper levels of their society. By 347 AD, oil was produced from bamboo-drilled wells in China. Early British explorers to Myanmar documented a flourishing oil extraction industry based in Yenanion, that in 1795 had hundreds of hand-dug wells under production. The mythological origins of the oil fields at Yenanion, and its hereditary monopoly controlled by 24 families, indicate very ancient origins. Modern history: in 1847, the process to distill kerosene from petroleum was invented by James Young. He noticed a natural petroleum seepage in the Riddings colliery at Alfreton, Derbyshire, from which he distilled a light thin oil suitable for use as lamp oil, at the same time obtaining a thicker oil suitable for lubricating machinery. In 1848 Young set up a small business refining the crude oil. Young eventually succeeded, by distilling cannel coal at a low heat, in creating a fluid resembling petroleum, which when treated in the same way as the seep oil gave similar products. Young found that by slow distillation he could obtain a number of useful liquids from it, one of which he named paraffin oil, because at low temperatures it congealed into a substance resembling paraffin wax. The production of these oils and solid paraffin wax from coal formed the subject of his patent dated October 17, 1850. In 1850 Young and Meldrum and Edward William Binney entered into partnership under the title of E. W. Binney and Company at Bathgate in West Lothian and E. Meldrum and Company at Glasgow. Their works at Bathgate were completed in 1851 and became the first truly commercial oil works in the world, with the first modern oil refinery, using oil extracted from locally mined turbonite, shale, and bituminous coal to manufacture naphtha and lubricating oils. Paraffin for fuel use and solid paraffin were not sold until 1856. Another early refinery was built by Ignacy Angstrom at Kasseowij, providing a cheaper alternative to whale oil. The demand for petroleum as a fuel for lighting in North America and around the world quickly grew. Edwin Drake's 1859 well near Titusville, Pennsylvania, is popularly considered the first modern well. Drake's well is probably singled out because it was drilled, not dug. Because it used a steam engine. Because there was a company associated with it. And because it touched off a major boom. However, there was considerable activity before Drake in various parts of the world in the mid-19th century. A group directed by Major Alex Shuev of the Bakinskaya Corps of Mining Engineers hand-drilled a well in the Baku region in 1848. There were engine-drilled wells in West Virginia in the same year as Drake's well. An early commercial well was hand-dug in Poland in 1853, and another in nearby Romania in 1857. At around the same time the world's first, small, oil refinery was opened at Jaseo in Poland, with a larger one opened at Ploiești unregistered trademark T in Romania shortly after. Romania is the first country in the world to have had its annual crude oil output officially recorded in international statistics, 275 tons for 1857. The first commercial oil well in Canada became operational in 1858 at Oil Springs, Ontario. Businessman James Miller Williams dug several wells between 1855 and 1858 before discovering a rich reserve of oil 4 meters below ground. Williams extracted 1.5 million liters of crude oil by 1860, refining much of it into kerosene lamp oil. Williams' well became commercially viable a year before Drake's Pennsylvania operation and could be argued to be the first commercial oil well in North America. The discovery at Oil Springs touched off an oil boom which brought hundreds of speculators and workers to the area. Advances in drilling continued into 1862 when local drill ashore reached a depth of 62 meters using the spring pole drilling method. On January 16, 1862, after an explosion of natural gas, Canada's first oil gusher came into production, shooting into the air at a recorded rate of 3,000 barrels per day. By the end of the 19th century the Russian Empire, particularly the Brunbel Company in Azerbaijan, had taken the lead in production. Access to oil was and still is a major factor in several military conflicts of the 20th century, including World War II, during which oil facilities were a major strategic asset and were extensively bombed. The German invasion of the Soviet Union included the goal to capture the Baku oil fields, as it would provide much-needed oil supplies for the German military which was suffering from blockades. Oil exploration in North America during the early 20th century later led to the U.S. becoming the leading producer by mid-century. As petroleum production in the U.S. peaked during the 1960s, however, the United States was surpassed by Saudi Arabia and the Soviet Union. Today, about 90% of vehicular fuel needs are met by oil. Petroleum also makes up 40% of total energy consumption in the United States, but is responsible for only 1% of electricity generation. Petroleum's worth as a portable, dense energy source powering the vast majority of vehicles and as the base of many industrial chemicals makes it one of the world's most important commodities. Viability of the oil commodity is controlled by several key parameters: number of vehicles in the world competing for fuel, quantity of oil exported to the world market, net energy gain, political stability of oil exporting nations and ability to defend oil supply lines. The top 3 oil-producing countries are Russia, Saudi Arabia and the United States. About 80% of the world's readily accessible reserves are located in the Middle East, with 62.5% coming from the Arab Five, Saudi Arabia, UAE, Iraq, Qatar and Kuwait. A large portion of the world's total oil exists as unconventional sources, such as bitumen in Canada and oil shale in Venezuela. While significant volumes of oil are extracted from oil sands, particularly in Canada, logistical and technical hurdles remain, as oil extraction requires large amounts of heat and water, making its net energy content quite low relative to conventional crude oil. Thus, Canada's oil sands are not expected to provide more than a few million barrels per day in the foreseeable future. Composition. In its strictest sense, petroleum includes only crude oil, but in common usage it includes all liquid, gaseous, and solid hydrocarbons. Under surface pressure and temperature conditions, lighter hydrocarbons methane, ethane, propane and butane occur as gases, while pentane and heavier ones are in the form of liquids or solids. However, in an underground oil reservoir the proportions of gas, liquid, and solid depend on subsurface conditions and on the phase diagram of the petroleum mixture. An oil well produces predominantly crude oil, with some natural gas dissolved in it. Because the pressure is lower at the surface than underground, some of the gas will come out of solution and be recovered as associated gas or solution gas. A gas well produces predominantly natural gas. However, because the underground temperature and pressure are higher than at the surface, the gas may contain heavier hydrocarbons such as pentane, hexane, and heptane in the gaseous state. At surface conditions these will condense out of the gas to form natural gas condensate, often shortened to condensate. Condensate resembles petrol in appearance and is similar in composition to some volatile light crude oils. The proportion of light hydrocarbons in the petroleum mixture varies greatly among different oil fields, ranging from as much as 97% by weight in the lighter oils to as little as 50% in the heavier oils and bitumens. The hydrocarbons in crude oil are mostly alkanes, cycloalkanes and various aromatic hydrocarbons, while the other organic compounds contain nitrogen, oxygen and sulfur, and trace amounts of metals such as iron, nickel, copper and vanadium. The exact molecular composition varies widely from formation to formation, but the proportion of chemical elements vary over fairly narrow limits as follows. 4 different types of hydrocarbon molecules appear in crude oil. The relative percentage of each varies from oil to oil, determining the properties of each oil. Crude oil varies greatly in appearance depending on its composition. It is usually black or dark brown. In the reservoir it is usually found in association with natural gas, which being lighter forms a gas cap over the petroleum, and saline water which, being heavier than most forms of crude oil, generally sinks beneath it. Crude oil may also be found in semi-solid form mixed with sand and water, as in the Athabasca oil sands in Canada, where it is usually referred to as crude bitumen. In Canada, bitumen is considered a sticky, black, tar-like form of crude oil which is so thick and heavy that it must be heated or diluted before it will flow. Venezuela also has large amounts of oil in the Orinoco oil sands, although the hydrocarbons trapped in them are more fluid than in Canada and are usually called extra heavy oil. These oil sands resources are called unconventional oil to distinguish them from oil which can be extracted using traditional oil well methods. Between them, Canada and Venezuela contain an estimated 3.6 trillion barrels of bitumen and extra heavy oil, about twice the volume of the world's reserves of conventional oil. Petroleum is used mostly, by volume, for producing fuel oil and petrol, both important primary energy sources. 84% by volume of the hydrocarbons present in petroleum is converted into energy-rich fuels, including petrol, diesel, jet, heating, and other fuel oils, and liquefied petroleum gas. The lighter grades of crude oil produce the best yields of these products, but as the world's reserves of light and medium oil are depleted, oil refineries are increasingly having to process heavy oil and bitumen, and use more complex and expensive methods to produce the products required. Because heavier crude oils have too much carbon and not enough hydrogen, these processes generally involve removing carbon from or adding hydrogen to the molecules, and using fluid catalytic cracking to convert the longer, more complex molecules in the oil to the shorter, simpler ones in the fuels. Due to its high energy density, easy transportability and relative abundance, Oil has become the world's most important source of energy since the mid-1950s. Petroleum is also the raw material for many chemical products, including pharmaceuticals, solvents, fertilizers, pesticides, and plastics. The 16% not used for energy production is converted into these other materials. Petroleum is found in porous rock formations in the upper strata of some areas of the Earth's crust. There is also petroleum in oil sands. Known oil reserves are typically estimated at around 190 km3 barrels, without oil sands, or 595 km3 with oil sands. Consumption is currently around 84 million barrels per day, or 4.9 km3 per year, which in turn yields a remaining oil supply of only about 120 years, if current demand remains static. Chemistry. Petroleum is a mixture of a very large number of different hydrocarbons. The most commonly found molecules are alkanes, cycloalkanes, aromatic hydrocarbons, or more complicated chemicals like asphaltones. Each petroleum variety has a unique mix of molecules, which define its physical and chemical properties, like color and viscosity. The alkanes, also known as paraffins, are saturated hydrocarbons with straight or branched chains which contain only carbon and hydrogen and have the general formula CnH2n+2. They generally have from 5 to 40 carbon atoms per molecule, although trace amounts of shorter or longer molecules may be present in the mixture. The alkanes from pentane to octane are refined into petrol, the ones from nonane to hexadecane into diesel fuel, kerosene and jet fuel. Alkanes with more than 16 carbon atoms can be refined into fuel oil and lubricating oil. At the heavier end of the range, paraffin wax is an alkane with approximately 25 carbon atoms, while asphalt has 35 and up, although these are usually cracked by modern refineries into more valuable products. The shortest molecules, those with 4 or fewer carbon atoms, are in a gaseous state at room temperature. They are the petroleum gases. Depending on demand and the cost of recovery, these gases are either flared off, sold as liquefied petroleum gas under pressure, or used to power the refinery's own burners. During the winter, butane is blended into the petrol pool at high rates, because its high vapor pressure assists with cold starts. Liquefied under pressure slightly above atmospheric, it is best known for powering cigarette lighters, but it is also a main fuel source for many developing countries. Propane can be liquefied under modest pressure, and is consumed for just about every application relying on petroleum for energy, from cooking to heating to transportation. The cycloalkanes, also known as naphthenes, are saturated hydrocarbons which have one or more carbon rings to which hydrogen atoms are attached according to the formula CnH2n. Cycloalkanes have similar properties to alkanes but have higher boiling points. The aromatic hydrocarbons are unsaturated hydrocarbons which have one or more planar 6-carbon rings called benzene rings, to which hydrogen atoms are attached with the formula CnHn. They tend to burn with a sooty flame, and many have a sweet aroma. Some are carcinogenic. These different molecules are separated by fractional distillation at an oil refinery to produce petrol, jet fuel, kerosene, and other hydrocarbons. For example, 2,4-tremethylpentane, widely used in petrol, has a chemical formula of C8H18 and it reacts with oxygen exothermically, to a C, 8 hours, 18, L, plus 25 AO, 2, G, A16 a CO, 2, G, plus 18 H, 2O, G. The number of various molecules in an oil sample can be determined in laboratory. The molecules are typically extracted in a solvent, then separated in a gas chromatograph, and finally determined with a suitable detector, such as a flame ionization detector or a mass spectrometer. Due to the large number of co-eluted hydrocarbons within oil, many cannot be resolved by traditional gas chromatography and typically appears a hump in the chromatogram. This unresolved complex mixture of hydrocarbons is particularly apparent when analyzing weathered oils and extracts from tissues of organisms exposed to oil. Incomplete combustion of petroleum or petrol results in production of toxic byproducts. Too little oxygen results in carbon monoxide. Due to the high temperatures and high pressures involved, Exhaust gases from petrol combustion in car engines usually include nitrogen oxides, which are responsible for creation of photochemical smog. Empirical equations for thermal properties: heat of combustion. At a constant volume, the heat of combustion of a petroleum product can be approximated as follows, where is measured in calorie per gram and D is the specific gravity at 60 AA degree Fahrenheit. Thermal conductivity. The thermal conductivity of petroleum-based liquids can be modeled as follows, where K is measured in BTU/AA degree Fa 1 Ra 1 FTA 1 A, T is measured in a degree Fahrenheit and API is degrees API gravity. Specific heat. The specific heat of a petroleum oils can be modeled as follows, where C is measured in British thermal unit lbm a degree Fahrenheit. T is the temperature in Fahrenheit and D is the specific gravity at 60 AA degree Fahrenheit. In units of kilocalorie/Ga a degree Celsius, the formula is, where the temperature T is in Celsius and D is the specific gravity at 15 AA degree Celsius. Latent heat of vaporization. The latent heat of vaporization can be modeled under atmospheric conditions as follows, where L is measured in British thermal unit lbm, T is measured in a degree Fahrenheit and D is the specific gravity at 60 AA degree Fahrenheit. In units of kilocalorie per kilogram, the formula is, where the temperature T is in Celsius and D is the specific gravity at 15 AA degree Celsius. Formation. Petroleum is a fossil fuel derived from ancient fossilized organic materials, such as zooplankton and algae. Vast quantities of these remains settled to sea or lake bottoms, mixing with sediments and being buried under anoxic conditions. As further layers settled to the sea or lake bed, intense heat and pressure build up in the lower regions. This process caused the organic matter to change, first into a waxy material known as kerogen, which is found in various oil shales around the world, and then with more heat into liquid and gaseous hydrocarbons via a process known as catagenesis. Formation of petroleum occurs from hydrocarbon pyrolysis in a variety of mainly endothermic reactions at high temperature and/or pressure. There were certain warm nutrient-rich environments such as the Gulf of Mexico and the ancient Tethys Sea where the large amounts of organic material falling to the ocean floor exceeded the rate at which it could decompose. This resulted in large masses of organic material being buried under subsequent deposits such as shale formed from mud. This massive organic deposit later became heated and transformed under pressure into oil. Geologists often refer to the temperature range in which oil forms as an oil window. Below the minimum temperature oil remains trapped in the form of kerogen, and above the maximum temperature the oil is converted to natural gas through the process of thermal cracking. Sometimes, oil formed at extreme depths may migrate and become trapped at a much shallower level. The Athabasca oil sands are one example of this. An alternative mechanism was proposed by Russian scientists in the mid-1850s, the abiogenic petroleum origin, but this is contradicted by the geological and geochemical evidence. Reservoirs, crude oil reservoirs. 3 conditions must be present for oil reservoirs to form: a source rock rich in hydrocarbon material buried deep enough for subterranean heat to cook it into oil, a porous and permeable reservoir rock for it to accumulate in, and a cap rock or other mechanism that prevents it from escaping to the surface. Within these reservoirs, fluids will typically organize themselves like a 3-layer cake with a layer of water below the oil layer and a layer of gas above it, although the different layers vary in size between reservoirs. Because most hydrocarbons are less dense than rock or water, they often migrate upward through adjacent rock layers until either reaching the surface or becoming trapped within porous rocks by impermeable rocks above. However, the process is influenced by underground water flows, causing oil to migrate hundreds of kilometers horizontally or even short distances downward before becoming trapped in a reservoir. When hydrocarbons are concentrated in a trap, an oil field forms, from which the liquid can be extracted by drilling and pumping. The reactions that produce oil and natural gas are often modeled as first-order breakdown reactions, where hydrocarbons are broken down to oil and natural gas by a set of parallel reactions, and oil eventually breaks down to natural gas by another set of reactions. The latter set is regularly used in petrochemical plants and oil refineries. Wells are drilled into oil reservoirs to extract the crude oil. Natural lift production methods that rely on the natural reservoir pressure to force the oil to the surface are usually sufficient for a while after reservoirs are first tapped. In some reservoirs, such as in the Middle East, the natural pressure is sufficient over a long time. The natural pressure in most reservoirs, however, eventually dissipates. Then the oil must be extracted using artificial lift means. Over time, these primary methods become less effective and secondary production methods may be used. A common secondary method is water flood, or injection of water into the reservoir to increase pressure and force the oil to the drilled shaft or wellbore. Eventually tertiary, or enhanced oil recovery methods may be used to increase the oil's flow characteristics by injecting steam, carbon dioxide and other gases or chemicals into the reservoir. In the United States, primary production methods account for less than 40% of the oil produced on a daily basis, secondary methods account for about half, and tertiary recovery the remaining 10%. Extracting oil from oil tar sand and oil shale deposits requires mining the sand or shale and heating it in a vessel or retort, or using in situ methods of injecting heated liquids into the deposit and then pumping out the oil-saturated liquid. Unconventional oil reservoirs. Oil-eating bacteria biodegrade oil that has escaped to the surface. Oil sands are reservoirs of partially biodegraded oil still in the process of escaping and being biodegraded, but they contain so much migrating oil that, although most of it has escaped, vast amounts are still present more than can be found in conventional oil reservoirs. The lighter fractions of the crude oil are destroyed first, resulting in reservoirs containing an extremely heavy form of crude oil, called crude bitumen in Canada, or extra heavy crude oil in Venezuela. These two countries have the world's largest deposits of oil sands. On the other hand, oil shales are source rocks that have not been exposed to heat or pressure long enough to convert their trapped hydrocarbons into crude oil. Technically speaking, oil shales are not always shales and do not contain oil, but are fine-grained sedimentary rocks containing an insoluble organic solid called kerogen. The kerogen in the rock can be converted into crude oil using heat and pressure to simulate natural processes. The method has been known for centuries and was patented in 1694 under British Crown Patent No. 330 covering, a way to extract and make great quantities of pitch, tar, and oil out of a sort of stone. Although oil shales are found in many countries, the United States has the world's largest deposits. Classification. The petroleum industry generally classifies crude oil by the geographic location it is produced in, its API gravity, and its sulfur content. Crude oil may be considered light if it has low density or heavy if it has high density. And it may be referred to as sweet if it contains relatively little sulfur or sour if it contains substantial amounts of sulfur. The geographic location is important because it affects transportation costs to the refinery. Light crude oil is more desirable than heavy oil since it produces a higher yield of petrol, while sweet oil commands a higher price than sour oil because it has fewer environmental problems and requires less refining to meet sulfur standards imposed on fuels in consuming countries. Each crude oil has unique molecular characteristics which are understood by the use of crude oil assay analysis in petroleum laboratories. Barrels from an area in which the crude oil's molecular characteristics have been determined and the oil has been classified are used as pricing references throughout the world. Some of the common reference crudes are, West Texas Intermediate, a very high quality, sweet, light oil delivered at Cushing, Oklahoma for North American oil, Brent blend, comprising 15 oils from fields in the Brent and Ninian systems in the East Shetland Basin of the North Sea. The oil is landed at Sullom Terminal in Shetland. Oil production from Europe, Africa and Middle Eastern oil flowing west tends to be priced off this oil, which forms a benchmark. Dubai Oman, used as benchmark for Middle East sour crude oil flowing to the Asia-Pacific region, TAPI, Minas, the OPEC reference basket, a weighted average of oil blends from various OPEC countries, Midway Sunset Heavy, by which heavy oil in California is priced. There are declining amounts of these benchmark oils being produced each year, so other oils are more commonly what is actually delivered. While the reference price may be for West Texas Intermediate delivered at Cushing, The actual oil being traded may be a discounted Canadian heavy oil delivered at Hardisty, Alberta, and for a Brent blend delivered at Shetland, it may be a Russian export blend delivered at the port of Primorsk. Petroleum industry. The petroleum industry is involved in the global processes of exploration, extraction, refining, transporting, and marketing petroleum products. The largest volume products of the industry are fuel oil and petrol. Petroleum is also the raw material for many chemical products, including pharmaceuticals, solvents, fertilizers, pesticides, and plastics. The industry is usually divided into three major components: upstream, midstream and downstream. Midstream operations are usually included in the downstream category. Petroleum is vital to many industries, and is of importance to the maintenance of industrialized civilization itself, and thus is a critical concern to many nations. Oil accounts for a large percentage of the world's energy consumption, ranging from a low of 32% for Europe and Asia, up to a high of 53% for the Middle East, South and Central America, Africa, and North America. The world at large consumes 30 billion barrels of oil per year, and the top oil consumers largely consist of developed nations. In fact, 24% of the oil consumed in 2004 went to the United States alone, though by 2007 this had dropped to 21% of world oil consumed. In the U.S., in the states of Arizona, California, Hawaii, Nevada, Oregon and Washington, the Western States Petroleum Association represents companies responsible for producing, distributing, refining, transporting and marketing petroleum. This non-profit trade association was founded in 1907, and is the oldest petroleum trade association in the United States. Shipping. In the 1950s, shipping costs made up 33% of the price of oil transported from the Persian Gulf to USA, but due to the development of supertankers in the 1970s, the cost of shipping dropped to only 5% of the price of Persian oil in USA. Due to the increase of the value of the crude oil during the last 30 years, the share of the shipping cost on the final cost of the delivered commodity was less than 3% in 2010. For example, in 2010 the shipping cost from the Persian Gulf to the USA was in the range of $20 per ton and the cost of the delivered crude oil around $800 per ton. Price. After the collapse of the OPEC-administered pricing system in 1985, and a short-lived experiment with net-back pricing, oil exporting countries adopted a market-link pricing mechanism. First adopted by PEMEX in 1986, market-link pricing was widely accepted, and by 1988 became and still is the main method for pricing crude oil in international trade. The current reference, or pricing markers, are Brent, WTI, and Dubai Oman. Uses. The chemical structure of petroleum is heterogeneous, composed of hydrocarbon chains of different lengths. Because of this, petroleum may be taken to oil refineries and the hydrocarbon chemicals separated by distillation and treated by other chemical processes, to be used for a variety of purposes. See petroleum products. Fuels. The most common distillation fractions of petroleum are fuels. Fuels include other derivatives. Certain types of resultant hydrocarbons may be mixed with other non-hydrocarbons, to create other end products, alkenes which can be manufactured into plastics or other compounds, lubricants. Wax, used in the packaging of frozen foods, among others. Sulfur or sulfuric acid. These are useful industrial materials. Sulfuric acid is usually prepared as the acid precursor oleum, a byproduct of sulfur removal from fuels. Bulk tar, asphalt, petroleum coke, used in specialty carbon products or as solid fuel. Paraffin wax, aromatic petrochemicals to be used as precursors in other chemical production. Agriculture. Since the 1940s, agricultural productivity has increased dramatically, due largely to the increased use of energy-intensive mechanization, fertilizers and pesticides. Petroleum by country. Consumption statistics. Consumption. According to the U.S. Energy Information Administration estimate for 2011, the world consumes 87.421 million barrels of oil each day. This table orders the amount of petroleum consumed in 2011 in 1,000 barrels per day and in 1,000 cubic meters per day. Source: U.S. Energy Information Administration. Population data. 1. Peak production of oil already passed in this state. 2. This country is not a major oil producer. Production. In petroleum industry parlance, production refers to the quantity of crude extracted from reserves, not the literal creation of the product. Source: U.S. Energy Information Administration. 1. Peak production of conventional oil already passed in this state. 2. Although Canada's conventional oil production is declining, its total oil production is increasing as oil sands production grows. When oil sands are included, Canada has the world's second-largest oil reserves after Saudi Arabia. 3. Trinidad and Tobago has the world's third-largest pitch lake situated La Brea, South Trinidad. 4. Though still a member, Iraq has not been included in production figures since 1998. In 2013, the United States will produce an average of 11.4 million barrels a day, which would make it the second-largest producer of hydrocarbons, and is expected to overtake Saudi Arabia before 2020. Export. In order of net exports in 2011, 2009 and 2006 in 1,000 bbld and 1,000 m³/d. Source: U.S. Energy Information Administration. 1. Peak production already passed in this state. 2. Canadian statistics are complicated by the fact it is both an importer and exporter of crude oil, and refines large amounts of oil for the U.S. market. It is the leading source of U.S. imports of oil and products, averaging 2,500,000 bbld in August 2007. 1. Total world production consumption is approximately 84 million barrels per day. Import. In order of net imports in 2011, 2009 and 2006 in 1,000 bbld and 1,000 m³/d. Source: U.S. Energy Information Administration. 1. Peak production of oil expected in 2020. 2. Major oil producer whose production is still increasing. Import to the USA by country 2010. Non-producing consumers, countries whose oil production is 10% or less of their consumption. Source: CIA World Factbook. Environmental effects. Because petroleum is a naturally occurring substance, its presence in the environment need not be the result of human causes such as accidents and routine activities. Phenomena such as seeps and tar pits are examples of areas that petroleum affects without man's involvement. Regardless of source, petroleum's effects when released into the environment are similar. Ocean acidification. Ocean acidification is the increase in the acidity of the Earth's oceans caused by the uptake of carbon dioxide, CO2, from the atmosphere. This increase in acidity inhibits life such as scallops. Global warming. When burned, petroleum releases carbon dioxide, a greenhouse gas. Along with the burning of coal, petroleum combustion is the largest contributor to the increase in atmospheric CO2. Atmospheric CO2 has risen steadily since the Industrial Revolution to current levels of over 390 ppmv, from the 180 300 ppmv of the prior 800,000 years, driving global warming. The unbridled use of petroleum could potentially cause a runaway greenhouse effect on Earth. Use of oil as an energy source has caused Earth's temperature to increase by nearly 1 degree Celsius. This rise in temperature has reduced the Arctic ice cap to 1,100,000 sqmi, smaller than ever recorded. Because of this melt, more oil reserves have been revealed. It is estimated by the International Energy Agency that about 13% of the world's undiscovered oil resides in the Arctic. Extraction. Oil extraction is simply the removal of oil from the reservoir. Oil is often recovered as a water in oil emulsion, and specialty chemicals called demulsifiers are used to separate the oil from water. Oil extraction is costly and sometimes environmentally damaging, although Dr. John Hunter of the Woods Hole Oceanographic Institution pointed out in a 1981 paper that over 70% of the reserves in the world are associated with visible macroseepages, and many oil fields are found due to natural seeps. Offshore exploration and extraction of oil disturbs the surrounding marine environment. Oil spills. Crude oil and refined fuel spills from tanker ship accidents have damaged natural ecosystems in Alaska, the Gulf of Mexico, the Galapagos Islands, France and many other places. The quantity of oil spilled during accidents has ranged from a few hundred tons to several 100,000 tons. Smaller spills have already proven to have a great impact on ecosystems, such as the Exxon Valdez oil spill. Oil spills at sea are generally much more damaging than those on land, since they can spread for hundreds of nautical miles in a thin oil slick which can cover beaches with a thin coating of oil. This can kill seabirds, mammals, shellfish and other organisms it coats. Oil spills on land are more readily containable if a makeshift earth dam can be rapidly bulldozed around the spill site before most of the oil escapes, and land animals can avoid the oil more easily. Control of oil spills is difficult, requires ad hoc methods, and often a large amount of manpower. The dropping of bombs and incendiary devices from aircraft on Saltaray Canyon wreck produced poor results. Modern techniques would include pumping the oil from the wreck, like in the Prestige oil spill or the Erica oil spill. Though crude oil is predominantly composed of various hydrocarbons, certain nitrogen heterocyclic compounds, such as pyridine, picolin, and quinolin are reported as contaminants associated with crude oil, as well as facilities processing oil shale or coal, and have also been found at legacy wood treatment sites. These compounds have a very high water solubility, and thus tend to dissolve and move with water. Certain naturally occurring bacteria, such as Micrococcus, Arthrobacter, and Hodococcus have been shown to degrade these contaminants. Tar balls. A tar ball is a blob of crude oil which has been weathered after floating in the ocean. Tar balls are an aquatic pollutant in most environments, although they can occur naturally, for example, in the Santa Barbara Channel of California. Their concentration and features have been used to assess the extent of oil spills. Their composition can be used to identify their sources of origin, and tar balls themselves may be dispersed over long distances by deep-sea currents. They are slowly decomposed by bacteria, including Chromobacterium violaceum, Cladosporium resinae, Bacillus submarinus, Micrococcus varians, Pseudomonas aeruginosa, Candida marina and Saccharomyces estuari. Whales. James S. Robbins has argued that the advent of petroleum-refined kerosene saved some species of great whales from extinction by providing an inexpensive substitute for whale oil, thus eliminating the economic imperative for open-boat whaling. Alternatives to petroleum. In the United States in 2007 about 70% of petroleum was used for transportation, 24% by industry, 5% for residential and commercial uses, and 2% for electricity production. Outside of the U.S., a higher proportion of petroleum tends to be used for electricity. Alternatives to petroleum-based vehicle fuels. Alternative fuel vehicles refers to both vehicles that use alternative fuels used in standard or modified internal combustion engines such as natural gas vehicles, neat ethanol vehicles, flexible fuel vehicles, biodiesel-powered vehicles, and hydrogen vehicles. Vehicles with advanced propulsion systems that reduce or substitute petroleum use such as battery electric vehicles, plug-in hybrid electric vehicles, and hydrogen fuel cell vehicles. Alternatives to using oil in industry. Biological feedstocks do exist for industrial uses such as bioplastic production. Alternatives to burning petroleum for electricity. In oil-producing countries with little refinery capacity, oil is sometimes burned to produce electricity. Renewable energy technologies such as solar power, wind power, microhydro, biomass and biofuels are used, but the primary alternatives remain large-scale hydroelectricity, nuclear and coal-fired generation. Future of petroleum production. Consumption in the 20th and 21st centuries has been abundantly pushed by automobile growth. The 1985 Euro 2003 oil glut even fueled the sales of low-economy vehicles in OECD countries. The 2008 economic crisis seems to have had some impact on the sales of such vehicles. Still, the 2008 oil consumption shows a small increase. The BRIC countries might also kick in, as China briefly was the first automobile markets in December 2009. the immediate outlook still hints upwards. In the long term, uncertainties linger. The OPEC believes that the OECD countries will push low-consumption policies at some point in the future. When that happens, it will definitely curb oil sales, and both OPEC and EIA kept lowering their 2020 consumption estimates during the past 5 years. Oil products are more and more in competition with alternative sources, mainly coal and natural gas, both cheaper sources. Production will also face an increasingly complex situation. While OPEC countries still have large reserves at low production prices, newly found reservoirs often lead to higher prices. Offshore giants such as Tupi, Gara and Tiber demand high investments and ever-increasing technological abilities. Subsalt reservoirs such as Tupi were unknown in the 20th century, mainly because the industry was unable to probe them. Enhanced oil recovery techniques will continue to play a major role in increasing the world's recoverable oil. Peak oil. Peak oil is the projection that future petroleum production will eventually peak and then decline at a similar rate to the rate of increase before the peak as these reserves are exhausted. The peak of oil discoveries was in 1965, and oil production per year has surpassed oil discoveries every year since 1980. Hubbard applied his theory to accurately predict the peak of U.S. conventional oil production at a date between 1966 and 1970. This prediction was based on data available at the time of his publication in 1956. In the same paper, Hubbard predicts world peak oil in half a century after his publication, which would be 2006. It is difficult to predict the oil peak in any given region, due to the lack of knowledge and/or transparency in accounting of global oil reserves. Based on available production data, proponents have previously predicted the peak for the world to be in years 1989, 1995, or 1995–2000. Some of these predictions date from before the recession of the early 1980s, and the consequent reduction in global consumption, the effect of which was to delay the date of any peak by several years. Just as the 1971 U.S. peak in oil production was only clearly recognized after the fact, a peak in world production will be difficult to discern until production clearly drops off. The peak is also a moving target as it is now measured as liquids, which includes synthetic fuels, instead of just conventional oil. The International Energy Agency said in 2010 that production of conventional crude oil had peaked in 2006 at 70 mbbld, then flattened at 68 or 69 thereafter. Since virtually all economic sectors rely heavily on petroleum, peak oil, if it were to occur, could lead to a partial or complete failure of markets. Unconventional production. The calculus for peak oil has changed with the introduction of unconventional production methods. In particular, the combination of horizontal drilling and hydraulic fracturing has resulted in a significant increase in production from previously uneconomic plays. Certain rock strata contain hydrocarbons but have low permeability and are not thick from a vertical perspective. Conventional vertical wells would be unable to economically retrieve these hydrocarbons. Horizontal drilling, extending horizontally through the strata, permits the well to access a much greater volume of the strata. Hydraulic fracturing creates greater permeability and increases hydrocarbon flow to the wellbore. See also: crude oil assay, barrel of oil equivalent, fuel, filling station, gas-oil ratio, gasoline, gross domestic product per barrel, hydrocarbon, list of countries by proven oil reserves, list of oil fields, list of petroleum companies, manure-derived synthetic crude oil, oil burden, petroleum geology, thermal depolymerization, total petroleum hydrocarbon, waste oil, tar sands, notes. References: Akinna, Shirin. Aldis, Anne, ed. The Caspian, Politics, Energy and Security. New York, Routledge. ISBN A978-0-7007-0501-6. Balgeorg, Bandy Mark Chance, Bandy Jean A. Tr. De Natura Fossilium via translated 1955, Hein, Norman J. Non-Technical Guide to Petroleum Geology, Exploration, Drilling, and Production. Penwell Corporation. ISBN A0-87814-823-X. Mabro, Robert. Organisation of Petroleum Exporting Countries. Oil in the 21st Century, Issues, Challenges and Opportunities. Oxford Press. ISBN A9780199207381. Moggieri, Leonardo. The Age of Oil, What They Don't Want You to Know About the World's Most Controversial Resource. Guilford, Connecticut, Globe Pequot. PA 15. ISBN A978-1-59921-118-3. Spate, James G. The Chemistry and Technology of Petroleum. Marcel Decker. ISBN A0-8247-0217-4. Spate, James G. Ancheta, Jorge, ed. Hydroprocessing of Heavy Oils and Residua. CRC Press. ISBN A0-8493-7419-7. Vassilia, Marius. Historical Dictionary of the Petroleum Industry. Scarecrow Press. ISBN A0-8108-5993-9. Further reading, Kavari, Faraday Oil and Islam, The Ticking Bomb. First ed. Malibu, California. Roundtable Publications. 277p, ill with maps and charts. ISBN 0-915677-55-5. External links, Petroleum at DMOZ, Petroleum Online e-learning resource from IHRDC, largest oil producers in the world, in depth, Brent and WTI crude oil. What makes price difference? U.S. Energy Information Administration, U.S. Department of Energy EIA. Euro World Supply and Consumption, who are the major players supplying the world oil market? American Petroleum Institute. Euro the Trade Association of the U.S. oil industry. Oil Survey. Euro OECD International Energy Agency, Oil and Gas Industry Learning Center. Euro Information on Oil and Gas Processes, U.S. National Library of Medicine, Hazardous Substances Data Bank. Euro Crude Oil, BP Statistical Review of World Energy 2012, Crude, 2007. Australian Broadcasting Corporation documentary, 3x 30 minutes about the formation of oil, and humanity's use of it.